Hi friends, welcome back to this my second part of this calculus integration. Don't forget we've treated differentiation, and if you are not good in differentiation, there is no way this integration will be familiar with you as you want it. Therefore, I will advise you to study your differentiation very well. So what is integration? Integration is the reverse form of differentiation. When we say reverse form, it's just as if we are taking or revising the differentiation. If we have y to be equal to x, and if we differentiate this with respect to x, our answer is going to be 1, right? As we studied in our differentiation. Therefore, to get this equation back again, we have to integrate this differentiation. Because if we don't integrate this, there's no way we can get back this function. Therefore, this process of integrating this differentiation is referred to as integration. We also call integration anti-differentiation. If you remember, if you take a logarithm of any number, to reverse that number or the log of that number, we take the anti-log of that number. Just as if we have virus and want to remove virus, what do we take? We take the antivirus to remove that virus. Likewise, when we differentiate, to reverse that differentiation and get the original function we differentiated, we need to what? Integrate. That is what you refer to as what? Integration. Now, we want to look at the first part of differentiation. If you notice, so we have a integration of polynomial function. Integration of polynomial function. If you still remember from our differentiation, we also studied differentiation of polynomial functions. If you recall, we said if our y is given to be x raised to the power of n, we differentiate this, the y, the x, to get n x n minus 1. We do subtract 1 from the power. Now, to get this function that we just differentiated, we have to integrate this again. And how do we do that? So we integrate this, the y, the x, equal to, we integrate this as well, x n minus 1. Now, we need to integrate this integrand with respect to the variable, which is the x. So we can write this as integral of the y equal to, when we cross multiply, this is the same thing as n x n minus 1 the x. So anywhere we have a constant term, we take it outside. So this is a constant term, and we can have this equal to, that is, we have integrated the y, and that will give us y. So to take this out, we have n integral x n minus 1 dx. So how do we integrate this? So have our y equal to n times x n minus 1. So the law of integration under this direct method, which is polynomial function, is whatever power we have here, we add 1 to that power. And we divide everything here. We divide everything here by the power again, which is n minus 1 plus 1. Then we need to add what you call constant term. And what is the function of this constant term? We will explain it later. So this will give us y equal to nx. So this will take care of this, and we'll have this all over. This take care of this, we'll have this, then plus c. This will also cancel this. We now have our y equal to x n raised to the power of n plus c. This is the answer. And if you check this, it's still the same thing as this. That is, we have this as a function. We differentiated this to get this. And to get this function back again, we take the process of integration. So this process of revising this back to this original function is referred to as integration. Therefore, integration is the reverse process of differentiation. Now, if you look at this original function given to us, there is no c. But here we have c. Then what is the function of this c? This c is known as integration constant, is integrated constant. Why are we putting c? That c stands for any constant value. Now, you may ask, if I have this function at 2 raised to the power of x squared plus 4, and I also have y equal to 2x raised to the power 2, if I differentiate this, what will be my answer? If I differentiate this function, that is the y, the x, you agree with me that I'm going to have this will be 4x. Then when you differentiate constant term, it will be 0. And if you also differentiate this, I will also have the y, the x equal to, this will also be 4x. And we discover that these two, there is no any difference. The only difference in their function is this constant term. But if we differentiate this and this, we are still going to get it. Therefore, we can have other functions, of which if we differentiate the function, they are going to give us the same answer like this. To avoid ambiguous answer from different people while integrating, it is advisable to put this c. That is, this c stands for any constant term. It may be 1, 2, 3, 1,000, 1 million, whatever constant. That is a constant without integration. So we must put this c. And if you differentiate this, that is, if we differentiate this function again, we try to differentiate this function. We have the y, the x equal to this will give us nx n minus 1, and when you differentiate this c, it will be 0 because it's a constant term, which is still the same thing as this. So that is why we are putting that constant term. And let's look at how we can differentiate with this procedure the polynomial function. There are some questions here. Let's look at examples. Examples: integrate the following functions with respect to x. We have number 1, we have an x squared plus 7x plus 5. We have number 2, we have a x minus 3, then square root x, 1, 2, 3. We have root x minus 1 over root x all raised to the power of 3. I'll have this as well. 4. We have x plus 2 into x minus 1 into x plus 5 into x minus 7. And the last one here, we have x squared plus 3x plus 4 all over square root of x. These are polynomial functions. And how do we integrate polynomial functions? We integrate polynomial functions using this direct integration method. And to solve the above questions, I will just explain the two. We're not going to solve everything. So let me solve number 1 first. So the first one, I will put the integral sign. I can say integral x squared plus 7x plus 5, all with respect to x. So I'm going to integrate each term here. This is the same thing as integral x squared plus integral, that is this to multiply this 7x, let's put the x here plus the x plus the x here. It is integral 5x. So here, if you integrate this using the same method, like I said, you have a x squared plus 1. You are adding 1 to the power, divided by the power again, which is 2 plus 1. Then plus, this is a constant term, times, so this power here is 1. We have x raised to the power of 1 plus 1 all over 1 plus 1. Then plus, this is a constant term, all you just do is to add x. Just add x to it by differentiating it. Then plus constant term, like I said, always put constant term to it. So this will give us x raised to the power of 3 over 3 plus 7x squared over 2 plus 5x plus c. So this is the integration of this. And if we differentiate this function again, we are still going to get this original function we just integrated. So you can also try this at our